Introduction. Welcome to the fascinating world of computer vision. Today we're going to delve into one of its fundamental concepts, feature extraction. Imagine teaching a computer to recognize a cat. How does it know what a cat looks like? That's where feature extraction comes in. It's the process of identifying and extracting specific characteristics from images or videos. These characteristics or features are what helps the computer understand and classify visual data. Let's break down how this magical process works. What are features? Features are the distinctive elements that define an object or scene. In an image, features could be edges, corners, colors, textures, or even shapes. For example, a cat's features might include its whiskers, ears, and tail. These features are like fingerprints for objects, unique and identifiable. By extracting these features, we create a numerical representation of the image. This numerical representation can then be used by machine learning algorithms to make predictions or decisions. So, feature extraction is the bridge between raw image data and meaningful information. Why is feature extraction important? Feature extraction is the backbone of many computer vision applications. Without it, computers would struggle to understand and interpret visual data. It allows for tasks like object recognition, image classification, and facial recognition. For instance, in a self-driving car, feature extraction helps the vehicle identify pedestrians, traffic signs, and other objects on the road. It also plays a crucial role in medical image analysis, where it can help detect tumors or other abnormalities. In short, feature extraction is the key to enabling computers to see and understand the world around them. Traditional feature extraction methods. Traditionally, feature extraction was done manually by experts. They would design algorithms to detect specific features such as edges or corners. Some common traditional methods include edge detection, histogram of oriented gradients, CHOG, and scale invariant feature transform, SIFT. While these methods were effective, they were often time-consuming and required domain expertise. With the advent of deep learning, a new era of feature extraction has begun. Deep learning for feature extraction. Deep learning, especially convolutional neural networks, CNNs, has revolutionized feature extraction. CNNs are designed to automatically learn the most relevant features from the data. They can extract complex features, such as hierarchical representations of objects. For example, a CNN might learn to recognize a cat by first detecting edges, then shapes, and finally, the overall structure of the cat. This hierarchical approach allows CNNs to learn highly discriminative features. The beauty of deep learning is that it can learn these features directly from the data, without the need for manual feature engineering. Applications of feature extraction. The applications of feature extraction are vast and varied. In the medical field, it can be used to detect diseases from medical images. In retail, it can be used for product recommendation systems based on visual similarity. In security, it can be used for facial recognition and surveillance. And in autonomous vehicles, it's essential for object detection and scene understanding. The possibilities are endless, and feature extraction is at the heart of many of these exciting applications. Conclusion. Feature extraction is a fundamental concept in computer vision. It allows computers to understand and interpret visual data by identifying and extracting meaningful features. From traditional methods to deep learning, feature extraction has come a long way. As technology continues to advance, we can expect to see even more sophisticated and powerful feature extraction techniques emerge. So, the next time you see a computer accurately recognizing an object in an image, remember that it's all thanks to the magic of feature extraction.